Hey guys, Mr. Backerberg here. In this video, we're going to take a look at one-to-one functions. Now let's compare what we know about regular functions versus a one-to-one function. So if we're talking about just a regular function, when you're dealing with a function, each input value is assigned to only one output values, but it's okay if output values get repeated. So visually, for an example, we've got input values of 1, 2, and 3. We've got output values of 4, 5, and 6. 1 is matched up with 6, 2 is matched up with 5, 3 is also matched up with 6. So each input value is only matched up with one output value. 1 isn't matched up with 4 and 6, it's only matched up with 6. But we did repeat an output value, but that's okay. Now if we compare that to a one-to-one function, each input value is assigned to one distinct output value. So this means that output values cannot be repeated. So visually here we have 1 still being matched up with 6, we have 2 being matched up with 5, but 3 can't be matched up with 6 like it was before because that would be a repeated output value. 3 is going to get matched up with 4 so that we are not repeating any output values. So that's the big difference between just a regular function and a one-to-one function, is whether or not you can repeat those output values. Mathematically speaking, we would say that a function is one-to-one on a specific domain D if f of a is not equal to f of b if a doesn't equal b. And that goes back to the whole idea of not repeating output values for different input values. Now visually, there is a test that we can use, so let's talk about a couple of graphs. We're going to look at the graph of y equals x cubed and y equals x squared. I'm going to do y equals x squared first. We know that one is a parabola shape, and on this parabola we repeat output values for specific places on that graph. So the test that we run to see if a function is one-to-one is the horizontal line test. And this graph fails the horizontal line test because this horizontal line hits this graph in two places, meaning that we're repeating that specific y value. But if we look at the graph for y equals x cubed and we draw in a horizontal line, nowhere on that graph will your horizontal line ever cross more than one point. So this one passes the horizontal line test, meaning that it is one-to-one. So in this example, we're going to determine whether this function is one-to-one. So we've got the function f of x equals the absolute value of x. Now if we use what we know about this graph, an absolute value graph is V-shaped heading out from the origin because this one doesn't have any shifts happening. So as far as the horizontal line test, this one would fail, so this one is not one-to-one. In this example, we're going to do the same thing. So thinking about the graph of the function f of x equals the square root of x, we're going to determine if it's one-to-one. So the square root of x is a sideways half parabola that keeps extending out forever and ever. But not only does it go out forever, it also increases very, very slightly as we go out. So for the horizontal line test, even though it's a very slight increase as x approaches infinity, it is still going up forever and ever and ever. So we will never ever repeat any output values. So this one passes the horizontal line test, so it is one-to-one. That's going to be it for this video. Thanks for watching.